Good day again, everyone. We're still on the strong numbers. And our lesson topic today is sets. Sets. Okay? Suppose I should provide you with these objects. If I should provide you with these objects and ask you to observe and describe them, I know a number of you will identify certain specific features, such as the colors, the rims. You might also want to associate with someone a car that you know, right? But if I ask you to use one word to describe all of them, the word that you will use is that they are all cars. So we can put them in a group and call them cars, right? So one word to describe these objects is that we can call all of them cars. How about if I provide you with these objects? Similarly, you would identify specific features because all of us use our senses differently. You might say you see a green or a blue, but one word we all can agree on to describe all these objects is that they are all called markers. So if we place them into a group, we can use one word to describe them. We can call them markers when we place them into a group. Similarly, if I should provide you with these objects and ask you what are they, you would say money. Some person might see something different. They might say, be more specific, they might say a $1 coin, $10 or $20 coin or $5 coin. But we can agree that if we should group them, we can call all of them Jamaican coins or money, right? So when we group these objects in our everyday life or in our surroundings, we can find words to describe all of them as a group, right? So hence our topic for today is sets. Now what is a set? A set is a group of markers, group of cars, group of coins. Is a group or collection of well-defined objects. So this is a well-defined objects. We can call these objects cars. We can call these objects money or coins. We can call these objects marker. A set is a group or collection of well-defined objects. So everywhere around us in our everyday life, we can group things, objects, and give them a specific name that describe all of them. We can see it in our house, right? We can group the utensils in our kitchen, the knife and the fork, and so forth. We can group the books, shoes, clothes in our home, right? We can group our family members and call them family. We can go outside the home and we can see things around in the environment in our yard. We can see trees, we can see cars, we can see houses on the road. When we're at school, there are things that we can put together. We can say the boys in 6A, the boys in 6S. We can group items and use one word to describe them. And when we group these items, we can call them sets. So a set is a group or collection of objects or well-defined objects. All right. Okay. So a set is a group of well-defined objects, right? So you can create your own set based on objects. So anything that have the same characteristics, one word that can be used to describe all of them is that we can group them and call them sets. All right. Okay. Now let's learn how to represent set. The first thing we're going to learn today on the set is how to represent sets. So for example, here we have a question. The set A consists of samples of Jamaican money in coins. So this is the normal everyday language that we use in language arts class or English. But in mathematics, math is a language. So we can translate this in the math language. This sentence, set A consists of samples of Jamaican money in coins. So how do we represent this statement, this sentence? In mathematics, we write set A. So the name of the set is written in capital letters, equal, and then we use curly brackets or braces to represent what we're going to talk about. So set A equal or consists of samples of Jamaican money. So we use capital letter to represent the name of the set and brackets or braces in which we put what we're talking about. So what we're talking about in this example, we're talking about Jamaican coins. So in this set, we could place some examples of Jamaican coins. So this is how we represent this English statement in mathematics language. So we represent the set by giving it a name, and the name of the set is always written in capital letters, and then whatever we are representing in the question is placed in brackets or braces. So this is how we represent this statement there. Now the objects that are placed inside the brackets to represent the set are called members or elements. So these objects inside of a set, when we're talking about set in mathematics, are called members or objects. So set A consists of samples of Jamaican money in coins. So remember, we always write the name of the set in capital letters, equal, and then we open and close our bracket, and then whatever the question is asking about, we place it inside the bracket, and that's how we represent a set. And the objects inside the set are called members or elements. Members or elements. So what does that mean? Since we can identify a $5 coin, a $1 coin, a $10 coin, a $20 coin, we can say that the $5 coin, the $10 coin, the $1 coin, $20 coin, there is a member or element of set A. So all these objects are a member of set A. Now, in sets in mathematics, we have what is called set notation. So it's a language of maths. So when we say that something is a member of or element of, we can represent it by writing these symbols. It looks like an E, and this E, the Greek letter, represents member of. So since the $1, $5, $10, $20 coin is a member of set A, we write this symbol, which is called a notation. Another word for symbol in math is notation. So we are doing sets. So the symbol in sets for member of is this symbol. Now, question I want to ask you. So based on what we have here, set A consists of Jamaican money in coins. Would you say that this money is a member of set A? No, because the statement said that coins, it consists of Jamaican money in coins. So hence, the $100 note is not a member of set A. So how can we write that using a math symbol or notation in set? So when a member or an element or an object is not a part of a set, we write it like this using this symbol. So we use the same symbol, but because it's not a member, we draw a line through it to show that it's not. So the $100 note is not a member of set A because set A only contains coins. Let's do another example. For example, if set B represents the names of students in grade 6 that drive to school. So set B represent the names of students in grade 6 that drive to school. If I ask to represent this information, how would you represent it? So the first thing we'd write set B, name of the set in capital letters, equal, and we open our brackets to all our members or our elements. But listen to the question or the sentence again. Set B represent the names of students in grade 6 that drive to school. Do you know of any students in grade 6 that drive to school? No, there is no student, because most students in grade 6 have a driver's license to drive to school. So this is how you represent this sentence. And when there is no member element with the braces there, we call this an empty set. So set B here is empty because no student in grade 6 drive to school. And this will be your solution. Now if we want to represent it as a notation using symbols, so we can use this symbol to represent empty set, or we can use this symbol. So symbol, another word for symbol in math is notation. So when an object is a member or element of, we use this symbol. When an object is not a member of, we use this symbol or notation. And when a set, when there's no member or element in a set, we say that it's empty, and this is a symbol for empty set. Okay? All right, let's go again. Let's talk about something else, the order of a set. Now in set, in mathematics, explanation, this represents the number of elements or members in a set. So we're talking about the order of a set. So the key word that you want to learn about now is the order of a set. So I'm explaining here that the order of a set, this means that the number of elements are members in a set. So what you do, when they ask about the orders, you're just going to count the amount of elements or members in the set. Let's look at this example. Set C contains even numbers less than 10. So to represent this, we write set, the name of the set in capital letters, set C is equal, we open our bracket. So set C contains even numbers less than 10. What are those even numbers less than 10? We have 8, 6, 4, and 2. So these are the even numbers less than 10. But the order of the set, to find the order of the set, we have to count the members. So after we write the set notation, we just count 1, 2, 3, 4. So we write the order by like this. So the number of members in set C equal 4. And that's the order. So the order is written like this. N for the number of set in set C, and we count the elements 1, 2, 3, 4 equal to 4. That's the order. Now another concept we want to talk about is the types of set. Now sets, there are two types of set. We have finite set, which you have learned from grade 5, and we have infinite set. Now from grade 5, you might remember that finite set represents sets of objects that we can count. countable. An infinite set represents a group of elements that we cannot count. So example of a finite set might be the number of letters in the alphabet. Say set D contains the number of elements in the alphabet. We can count them because there are 26 letters in the alphabet. No? The number of students in 6A, that's countable. We can count them. But infinite set represent things that we cannot count. For example, the number of fishes in the sea, the number of hairs on your head, number of sand grain on the beach, number of stars in the skies. Okay. So that's where we're gonna stop today. So today you're supposed to learn about how to write set notations for member of, not a member of, order of set, empty set, and to explain the different types of set.